Hello all. In today's class we'll discuss different types of mechanism, degree of freedom for various mechanisms, and Douglas equation. So basically, up till now we discussed degree of freedom is nothing but independent coordinates required to describe the position of mechanism with respect to fixedly at any given instant. So we have discussed two types of mechanism. One mechanism is a planar mechanism. Okay, it has a motion in a planar direction, which is then motion along x, y, z direction, that is in parallel plane with respect to reference plane. So to calculate this degree of freedom, we have to use a Douglas equation. That Douglas equation is nothing but n is equal to 3 n minus 1 minus 2j minus h. L is number of links, j is number of lower pair, h is higher pair. So we have solved some examples related to 4-bar chain. So in case of 4-bar chain and 5-bar chain, we come to know that how many degree of freedom is required to operate the system. So in case of 4-bar chain, number of links 4, number of pairs are 4. So only single degree of freedom is required. So in case of 5-bar chain, again number of links are 5, number of pairs are 5. Okay. So based on this, we can evaluate the degree of freedom. So for 4-bar chain, we have degree of freedom is 1. And in case of 5-bar chain, we have the degree of freedom value is 2. So in 4-bar chain, only single input is required. So to operate link number 2, that link 2 will rotate in circular direction, link 3 will get oscillate, link 4 will get rotate. Similarly, in case of 5-bar chain, what will happen? Rotary motion from link 2 will get transferred to rotary motion at link number 5. So hence we require two inputs will require to operate the system. Now, in case of say the structure of frame is connected with the help of intermediate member. Again, if you look at this arrangement, the number of links are 6, number of lower pairs are 7. Okay, so this is 1, 2, 3, 4, 5, 6, 7. So this structural frame or hatching line will act as a single link during motion transmission. So if you put all these values of number of links, number of pairs, then we'll get the graph freedom as 1 for this arrangement. Okay. Then next part is just look at the flow for this mechanism. Suppose the three links are connected at a single point. Okay, so there will be two joints we have to consider. So for such arrangement, number of links are this is first link, second link, third link, fourth link. Number of links are 4. Number of pairs, lower pairs 1, 2, 3, 4, and 5. So number of lower pairs are 5. Okay. Similarly, if you consider example of a gear, okay, a gear pair. So in case of gear pair, what we have, this is link number 1, this is 2, this is 3. Number of links are 3. Again, pair, first pair, second pair, so 2 lower pairs there, and 1 higher pair is there. So if you put the value of number of links, number of lower pair, number of higher pair, we get degree of freedom. So this arrangement degree of freedom is 1. Similarly, if you consider welded joint, what will happen for welded joint? We have number of links 1, 2, and 3. Okay. And number of lower pairs are this is first pair, this is second pair. Because this is completely welded to this particular gear. Okay. So it has only 2 terminal pair and 1 higher pair. So then if you put the value, then at that time we get the graph from as 1. F is equal to 3 and minus 1 minus 2 and minus h. But putting n is equal to 3, lower pair is equal to higher pair 1, we get the graph from 1 for such arrangement. Okay. Now next is Gresham law. We discuss Gresham law. Now what is the Gresham law? Suppose if you consider a 4-bar chain, okay, and if you want to show motion transmission between input link and output link, then the sum of length of shortest link, okay, and longest link should be less than sum of other two. That means if you consider this L and this S, this is P, this is Q. So shortest and longest link. Shortest link is crank, and this is your coupler. So length of coupler and crank should be less than length of this fixed link and other link, output link. That is the case. So if you apply this equation, then and then your system will work in proper direction, and then motion transmission is feasible. Otherwise, motion transmission is difficult between input link and output. So based on these concepts, we have different types of inversion that we have to study. So we can either fix different linkages, and based on fixing different linkages, we get the different motion transmission. So we have 3 different kinematic chain: 4-bar chain, single scatter kind chain, double scatter kind chain. So in case of 4-bar chain, the fixed link not to consider as a reference link. Based on permissions of different link, we can trace the trajectory or you can say path. Okay. So motion transmission and path transmissions we can decide based on the argument of that fixed link. Okay. So for 4-bar chain, we have this inversion. Okay. This is just 1 minute. Just possible. This is a fixed link, and we have these 4 combinations for this 4-bar chain: link 1, link 2, link 3, link 4. Okay. Now, by fixing different configurations, like first configurations, we are getting rotary motion as an input and output as a rotary motion. So motion transmissions will get occurred from input to output, and this type of arrangement is used in wiper mechanism in car. So whenever we are cleaning the car of any vehicle, we have to just mount that wiper on link number 3. As you rotate crank, that wiper may get oscillate about this fixed position, and so that we can clean that particular glass. Now, depending upon area of that particular glass, we can change the dimensions of wiper. Okay, so this is the special mechanism where we are achieving rotary motion as input. Again, finally, you are getting rotary motion as output. But in between rotary to rotary, we are targeting the trajectory of that coupler or you can say oscillator link, and we can clean that particular pattern. Okay. Now, next part, we have 3 different inversions for this 4-bar chain. Just look at the flow, how the system is working. So this is the rotary movement of that 4-bar chain. Intermediate link is a oscillator link. Again, we are tracing rotary motion at output, and this is the path traced by that particular system. Okay. That path is a oscillatory path. Okay. So for various configurations, these are the 4 inversions which are available for 4-bar mechanism. Just look at the flow. This is first inversion. So in first inversion, this is a fixed link. Motion transmission is from rotary to rotary. In second inversion, this is the fixed link. Oscillatory motion will get transferred from L to Q, that is link number 1 to link number 3. This is the combinations of oscillatory motion. In link 3 again, rotary motion to rotary motions we are focusing. And link 4. Now this 4 configuration is not be possible because it may happen that the link may get crossed to each other at point C. So this is a point S where link number L and Q will get connected to each other, cross to each other. So it may happen that the motion transmission is not feasible for this 4th criteria. So we can transfer motion by using first combinations. Link 1 is fixed, rotary to rotary. For second combinations also oscillatory motion is feasible. For third is also feasible, but at 4th, it will not be feasible to transfer motion from input to output. Okay. So stop here. Next class we'll discuss the part of inversion of 4-bar chain.